Hey everyone, on this lesson we will make a brief introduction to IP networks. This is the first lesson of this section on IP networks, so let's present the index. We will begin this section by introducing IP networks, so we will have a small introduction. Then we will study addressing and subnetting. Okay, this is going to be a very important subsection, and we will work on different problems. Subnetting is a very important aspect on IP networks. Then we will continue to study routing, also the ARP protocol, the IP header, the ICMP protocol, the DHCP protocol. Later we will study what is NAT or NAT, what is the NAT mechanism. Also we are going to work with the RIP dynamic routing. And finally we are also going to give some security notions on IP network. So for now, let's begin by introducing IP networks. Everything that concerns the management of IP networks is found in the data link, network, and transport layers. These three layers are responsible for the Internet Protocol. In the Internet Protocol, the base information is the datagram, also known and denoted as the IP packet. Now, on the Internet Protocol, datagrams fulfill three important properties. First of all, they are connectionless. This means that each datagram is independent of the others and can be delivered in no particular order. Secondly, we also follow the best effort mechanism. This means that each datagram is treated to the best of its ability. And finally, we also have the property of the unreliability. This means that the datagram can be lost and there is no recovery mechanism. So here to visualize this connectionless property that we know that each datagram is independent of the others and can be delivered with no particular order, just consider this example. We have here an IP network. Okay, we have the source application, the source host, and then we have the destination host. So here we send three datagrams. We first send the 1, then we send the 2, and then we send the 3. And here, as the destination host receives it, it receives first the 2, then the 1, then the 3. So here it doesn't matter the order that we send them, okay, because they are independent of each other. So essentially, if we are sending the datagram 1, we don't need to be worried if the datagram 2 was already sent or if the datagram 3 has already arrived to the destination host. Here they are independent. So now, as we can see here on this figure, in contrast of this IP network, we have here below a telephone network. So a telephone network is not connectionless. A telephone network is a connection-oriented service. As a consequence of this, the telephone network requires authentication. Another important example of a connection-oriented protocol is the TCP protocol. This is a connection-oriented. And coming back to the IP networks that they are connectionless, the UDP protocol is connectionless. So we'll see and study this in the future. But on one side we have the TCP protocol, which name is Transmission Control Protocol. This is a connection-oriented protocol. And then we have the UDP, which is User Datagram Protocol, that is also connectionless. Okay, the same as the IP network. So for now, very important here to distinguish, okay, the IP network is connectionless, and we can see the difference between the telephone network that is a connection-oriented network. So on the Internet Protocol, we have three types of datagrams according to who is the destination. If we have only one single and unique destination on datagram, this is called a unicast datagram. If we have that this datagram goes to all possible destinations on the source host's network, this is called a broadcast datagram. And finally, if this datagram goes to a given group of destinations, we can be here anywhere, this is called a multicast datagram. Let's visualize all these three types of datagrams in IP networks. So first we have the unicast, we have only a single destination. So here just consider we have the source host. Here we have the source, basically this computer in here, this source application, this is the computer, this PC. So we want to go from this PC to this destination PC. So we only have one destination. So this datagram is going to travel on one way. Firstly, the source host network, okay, it is going here to pass by this network, then it is also going to pass through another network, and finally this last network here, okay? So 3 different networks that this datagram is going to traverse and also travel until it reaches the destination host. Let's now see the example of the broadcast datagram. In this case, we have all possible destinations inside the source host network. So as we can see, if we want to send the broadcast from this source host, since this computer is inside this network that we see here, okay, and we send the broadcast datagram, this broadcast datagram is going to here arrive to this PC because it is also connected to this same network, to this other PC, connected to the same network, and finally this PC in here. So 3 PCs, 3 destinations, right? Very important, a broadcast datagram cannot travel through another networks. Only the same network as the source host is transmitting. Very well, so now finally we have the multicast datagram where the destinations are a group of applications, right? And the idea that this can be anywhere, okay? In a multicast datagram, we can basically traverse, we can travel through other networks, right? For instance, we want here from this PC, we want to go to this PC, to this application, to this other destination application, finally to this destination as well. So we go here, we travel this network, okay? This same network, this datagram reaches this PC, then we travel this second, so this datagram reaches this PC, and the same here of this multicast message, we go through this network to this PC and through this other network to arrive to this destination application. So the objective of the network layer that resolves the IP protocol is to deliver datagrams from a source host to a destination host by passing through one or more networks. This is the objective of the network layer. As a consequence of this, 2 matters of interest are generated. Firstly, the IP address. This is the manner, the way in which hosts, routers, and networks identify themselves, so this is very important. The second matter is the IP routing. Okay, this is the way in which datagrams travel over the network, so essentially the way datagrams are routed. So we will study deeply these 2 aspects in the following lessons. For now, we end this brief introduction lesson to the IP networks. The most important part is that you understand that the layers responsible for the Internet Protocol are the data link, network, and transport layers. The base information is the datagram, and we have 3 types of datagrams depending on who is the destination.